Today's topic is just in continuation of that of Tuesday. And if you look at it, we have models for population structure. We have what we call random mixing, people coming at random. We have what we call multiple group. And then we have what we call the special mixing, the network individualized based model. Population heterogeneity. In real populations, almost everybody is heterogeneous. No two individuals are completely alike. So it means we have different people with different individual differences. Which heterogeneities are important for the question at hand? Do they affect epidemiological rates or mixing? Can parameter be estimated to describe their effects? Often model using multiple group models, but network, IBMs, and PD partial differential equations also useful. An example now is something like this. This is what we call the SIR output epidemic curve. Susceptible for S, I, the infected, R for recovery. If you look at the graph there, the proportion of the population and the time, susceptible, infectious, and removed. And then you have the differential equation there. Today, I want to limit as much as possible. I don't want too much equation because I'm aware that we are not all in mathematics. Some are from computer background, some are from social sciences. Now, if we look at SIR outputs, the stochastic effects, here we have what we call 6 stochastic epidemics with R not equal to 3. We have the proportion of the population versus the time. What is the stochasticity here? The risk of disease extinction when number of cases is small, even when R not greater than 1. Then probability of disease extinction following introduction of the one single case is what we have next there. Probability of extinction versus the reproductive number. Next, we have a SIR with post-demographic epidemic cycle. Here we are talking in terms of the death is also included in the model. That's what we're saying. Susceptible, natural death is there. In the infected class, natural death is there. Recovered class, natural death is there. And they have the differential equation as that. Like I said earlier, I want to limit this issue of equation so that some people will not be living. I want everybody to enjoy. So if we look at the graph there, we have the proportion of the population versus the time. Cycle period where T is equal to 2 pi A G everything raised to power half, where A means the mean age of the infection, D the disease general interval, and can solve T in terms, we can solve T in terms of SIR model parameter by linearization. Next, if we look at this one, the SI phase plot, where you are trying to talk about the infected number of people versus the months. And then we have the infected versus the susceptible. When I want to, towards the summary here. So, summary of the simple epidemic patterns. Absence of recovery, logistic epidemic. No susceptible recruitment, that is, no birth and no loss of immunity. Simple epidemic. Susceptible recruitment through birth, that is loss of immunity, recurrent epidemics. And if you look at the equation there, we have the class there, but like I said earlier, for today, I want to limit the issue of using mathematics because it's only meant for those of us in mathematics and maybe those in physics. We are what we call the herd immunity and epidemic cycling. Herd immunity prevents further outbreaks until X susceptible versus over the total number N rises enough so that we now have the effective reproductive number greater than 1. And you can see the curve there. The graph there is proportion of the population versus the time. The classic example is measles in London of that same epidemic cycle. Next, herd immunity and epidemic cycling. Measles in London. The baby boom, the vaccination era, and if you look at the graph, cycle period depends on the effective birth rate. Persistence and fade out. Measles again, that's the continuation here of the UK. Over 60 million people are affected. And in Denmark, note that measles die out between major outbreaks in Iceland, but not in UK or Denmark. What determines persistence of an acute infection? And the questions like this are where what we call the autophages can cause problems. So what are we saying here? Intrinsic versus extrinsic forcing. What determines outbreak timing? Untangling the relative roles of intrinsic forcing, population of dynamics and herd immunity, and then extrinsic forcing, environmental factors and exogenous input is a central problem in population ecology. And towards the tail of my today's lecture, we'll be able to see where I said those people that may want to learn more about modeling some area for research. That is area that is in fact open for people to still learn more. So, untangling the relative role of intrinsic forcing, population dynamics, and that, searching for. So, next is, here if we look at also an example here, whose population size and structure, recruitment rates, and the herd immunity. What are those things? Factors. Host population size and structure, recruitment rates, and herd immunity. These are the factors for the intrinsic. For the extrinsic, we have what we call pathogen introduction, contact with reservoirs, invasive species, rain shifts, climate, warming temperature, malnutrition from climate, fisheries, and increasing the number of N, the pollution, etc. Then the human interaction. When we are harvesting, especially for the fish, if somebody is into fish farming, snail, and what have you, then we have what we call protection and disturbance. Data needs. What is needed to build a model? This is also very, very important. Individual clinical data. The data I use for this today's lecture is picked from the standardizers, London and some other advanced country. Individual clinical data, latent period, time from infection to the period of transmission, which we call the transmissibility, infectious period, duration and intensity of shedding, that is infectious stages, then immunity, how effective and for how long will somebody be immune, population data, population size and structure, birth and death rates, survivor, immigration and emigration, rate of contact within and between population groups. These are some of the things that in Nigeria here is difficult to be able to get. Epidemiological data, transmissibility R0, where you talk about density dependence and seasonality. Here we are talking just like what we have if we pick a textbook written by Box and Jenkins under time series analysis, where you talk about cyclical, seasonal, and what have you there. So data needs part 2. What is needed to validate a model? Incidence for the time series. We have the number of new cases, and that is what they normally report by our committee here, the Presidential Committee on COVID-19. Prevalence is a proportion of population with disease, and usually this one is expressed in percentage. Seroprevalence and seroincidence shows individuals' history of exposure, age, sex, special structure, if present, e.g., the mean age of the infection, can estimate R naught. Then we have what we call cross-sectional data. It's a prevalence survey or prevalence of chronic disease. Endemic. It means the disease is already inside at steady state, insight into mixing. Epidemic disease, outbreak size, attack rate, and risk. It means in fact almost the total number of X is almost equal to I. That is susceptible is almost equal to when you talk about pandemicity. Now, if we look at the next thing there, contact tracing, just like I explained. Sorry. Contact tracing. SARS, this was transmission chain in Singapore of 2018, where they need to have a data of getting people that are infected from house to house. So you do what you call contact tracing. So, and you can see the acknowledgement there. Household studies, observe time interval between 2 cases of measles in families of 2 children. Data from England from 1946 to this. If you look at the number of reported cases and the number of days, presumed doubled primaries, presumed within family transmission, and the latent period 6 to 9 days. The infectious period 6 to 7 days. Average serial interval 10.9 days. Other fields of disease modeling. It's also very, very important for people to be able to understand. Within host model, we have what we call pathogen population dynamics and immune response, where you talk about productively infected, especially for HIV CD4 counts, where you have an Amapi, one of the participants also, his PhD was on HIV AIDS, that's Dr. Opeyemi, he has already joined, he worked with me. So, where we look at the CD4, then latently infected CD4, and then you see the uninfected. Look at the take time, you see the within host models. This is what we call this type of thing. Now, community dynamics of disease. We have what we call co-infection. What happens when multiple parasites are present in the same human being? That is what we are talking about, co-infection. It's possible for somebody to have malaria, at the same time have tuberculosis. What happens when multiple parasites are present in the same host? How do they interact? Resource competition, immune-mediated, indirect competition, facilitation via immune suppression. Then we have what we call multiple host species. Many pathogens infect multiple species. When can we focus on one species? And how can we estimate importance of multiple species effects? People in medicine, public health in particular, also people in zoology department, many infection of human have animal reservoir. Example is what we call the bird flu, the TB, yellow fever, which in fact, according to a paper of just about two days ago, and then we have what we call the Rift Valley fever, reservoir and spillover species, host jump and pathogen emergence. These are some of the terminology. But let us just briefly give continuation of what we call the R naught. As long as I said I want to minimize the issue of pure mathematics here. But anybody that is interested can equally see me. The essence of bringing in the example 1 and 2 is just to be able to show more how to compute what we call reproductive number. So the R naught, rearranging the population so that we start with the infectious class, we obtain the EDT there, the IDT, the SDT, and the T. In the case where we have M equal to 2, that is, we have 2 infected compartments. And then we use what we call the V that I've just defined 2 days ago. Find a V as well there. And then if that is done correctly, we're going to get this. The disease-free equilibrium point of the system has coordinates E asterisk, I asterisk, S asterisk, and T asterisk for the tuberculosis. These are the two distinct, because the two compartments here is the exposed and the infected class. So we have 0, 0, 1, 0. The derivative of V and V at that is given as that, and then R naught is given as the spectral radius of what we have there. Again, if we consider another compartmental model that is just 3 classes, where the infected class is now further divided into I1, I2, and then you have the susceptible class. So it means also here, if you follow closely, just like the example 1 there, you have the 2 compartments there, the I1 and I2 there. So the disease-free equilibrium there, the derivative of V and F. So the reproductive number of the model is given as this. Now, a tool that we often use as part of analysis also is what we call the optimal control. Any good student of mathematical modeling must do algebra, both at master's, functional analysis at master's, complex analysis, topology, mathematical methods, and then numerical analysis, one optimization courses, one course from optimization, and 4 modeling courses. That's the way we do it here in Ilorin. The optimal control is to be able to tell us at what particular value will that thing be, in fact, are we going to have the optimal level? And that's the essence of this optimal control. But I now use just an elementary way to explain. If we have something like this, minimize integral 0 to 1 u of t raised to power 2 dt subject to the following thing here. We use what we call the Hamiltonian. So here, that is the optimal control written by Susan Lahart. H is that's a formula, the way we follow the thing because of that of u of t squared there. We put it there. That we have our lambda of x plus u, the optimality condition. We do partial differentiation with respect to u there. And then we have our atomic, the u asterisk, the subject of equation. We see the problem of minimization as we don't need, even if that MIN is omitted, one can still be able to know, because if you carry out the second partial derivative, since 2 is greater than 0, we already know that it's a minimization. So then the adjoint equation is what we have there. So for some constant C, then we find but the transversality condition is lambda of 1 equal to 0. Compute, we want to, the essence of doing that is to be able to know our constant there, which is 0. Then the lambda we set, because we are giving some condition there, we get the optimal solution as lambda equivalent to 0, u asterisk 0, s asterisk of t is et. The same thing, example 2 there. Follow the same procedure where the h means the Hamiltonian equation there, find the optimality condition, we are given that subject to so thing there, we put it there, we get this. But anybody that wants to see, get more thing, because the essence of today's lecture is to limit the usage of mathematics. But I want people also to be able to see some areas where they can do modeling. Now, if you look at this, apart from using optimal control, we equally use what we call Lyapunov analysis. The essence of the Lyapunov is to, if you want to now say categorically that the thing is globally asymptotic stable gas, then you use this. That is, after getting your equation, you now find the V of the first one, and that's just an example there. And then example 2 also there. Like I told you today, I don't want to, yes, this is where I will spend more time now. What are the areas? Because the topic given to me is the application of mathematical modeling to real life situation. Air pollution. If we look at the overview, we have what we call the local pollution in urban, smog, toxic releases, acid rain, global tissues, and what have you, and related chemicals. Typically aspects addressed by modeling. Anybody that is interested can decide to say, I want to work on mathematical modeling of air pollution, where the person will work more on concentration, health impact, the trends, impact and cost-benefit analysis of proposed control measures. Another area, anybody that is interested in modeling could be mathematical modeling of water pollution. In Lagos, rivers, and some other states where you people have Lokoja in Kogi, even Kwara here in Jeba, Niger also, we are part of this thing. Somebody can decide to say, okay, I want to work on water pollution, mathematical modeling, where we talk about sewage, agricultural runoff, these are the overview thing, pesticide residues, acid rain, chemical discharge. Relatively few people in the world have access to clean water. Then what are those things? The person will focus more. The transport and environmental fate of pollutants and the effectiveness of remedial measures. If you are talking about water pollution, what are those things? Somebody that is interested in modeling. You look at the transportation of those particles, look, incorporate the environmental fates of those pollutants. Then that would be good. Groundwater modeling. Availability of groundwater and investigation or remediation of contamination problems, especially if we talk about borehole thing and some other things there. Excuse me. Save yields from wells, direction and rate of movement, spread of contaminants, evaluation of remedial measures. Water supply. Somebody could be interested in water supply. What am I trying to say? Almost every area now in Nigeria, we have people selling pure water, bottled water, and what have you there. So there are many notable instances where surveys of groundwater is being used at a non-susceptible rate. Determining the capacity of supplies, that's where the person can talk about transportation, model, and what have you. Effectiveness of the policy and incentive programs. Global warming. Greenhouse gases, such as carbon dioxide, cause more of sun's energy to be retained by the earth, leading to a rise in average temperature. Typically, aspects addressed by modeling, interactive effects of greenhouse gases, sunlight reflection by aerosols, and increased cloud cover, changes in vegetation, economic impacts on agriculture, sea level changes, just like you have a freshwater research institute in Lagos, and I think also one in New Busa also. Now, overview. Melting of polar ice due to increase in global temperature could redefine coastline, displace population, and affect ocean currents and climates. Feedback loops. Large ocean may lead to a higher amount of evaporation, more water in cloud states, perhaps more reflection of solar energy. I'm equally coming to that solar aspect too. Forest destruction, where we see so many people cutting this tree cutting and so many other things. What are the overview? Inject more greenhouse gases into atmosphere, reduces world photosynthetic capacity, which removes carbon dioxide and also leads to what? Erosion, shifting of waterways, and species loss. Then a modeler, what are the areas he needs to look at? What will be the role of forest as carbon reservoir in the world climate models? What will be the impact on deforestation of trade policies or economic incentives? Here we have along in between Makwa, Nebusa, we have some park there where it's boldly written, don't hunt here. That is, one, you don't do the cutting of trees there, and one must not shoot any animal. So, ozone depletion, certain chemicals, just like what we call the depletion ozone in the stratosphere, such ozone sheds the surface from ultraviolet light, which can harm humans, plants. Short and long-term ozone prediction, quantifying physical and economic impact on health and agriculture, effect of CFC replacement. Then hazardous material, an issue. It's also an issue, an area that somebody can decide to say, I want to work on another model of hazardous materials. What will be the overview, the general overview the person will be looking at? Dangers to the public and the environment from both planned and unplanned releases. Then, typical aspect addressed by modeling: concentration, transport through environment, population exposure, health effects, probability and effects of accidents. Solid waste. Now, when you talk about solid waste here, management and disposal of municipal solid waste, industrial waste, and miscellaneous waste, etc. Somebody that wants to work on that will have to look at the typical aspect that has to be addressed with the evaluation of both technical, cost and benefit aspect under certain future scenario regarding quantities and characteristics. Each of these I'll be talking, and I'm happy some of my past PhD, including Dr. Ayuade Ampasho, he has joined. Dr. Abraham Augustine was also with us about 2 days ago, he joined. So what I'm trying to say here, one of my students also work on what we call the solid waste, and where we look at the way we do waste management, especially a case study of Kwara State. Almost every street you go to, you discover that Kwara State government will say, okay, just put your waste there, and they have a vehicle that will convey. But what we are now saying is, what are some of the health implications and so many other things? These are some of the things we consider, and we, in fact, one of the things that we were able to say is that we can convert most of those waste into what we call electricity, just like it was done in Singapore and so many other advanced countries. That is from waste to wealth. Hazardous waste. The difference between hazardous material and the waste from the hazardous material is what we call hazardous waste here. Hazardous waste are now variously incinerated, where they will just build a particular thing, bury, reprocess, or otherwise treated for disposal or reuse. Here again, for somebody that is interested in that, the person needs to look at the environmental effect of various disposal systems, where the person will say, okay, let me now separate this into two. This is what we call home use, and these are the industrial waste. Then you have another, the third compartment, where they will do the disposal. From the disposal, they now do what they call another, the fourth compartment will be, how can you reuse this? And the last one will be what we call the biogas, that will generate electricity. That was what that my students work on. Now, ocean population. Years of routine dumping of waste material at sea by many nations make it difficult to control this practice, despite some treaties. Environmental fate of materials disposed of at sea, both in the physical environment and in the food chain. Then we have what we call environmental impact analysis. Here also I need to just give more elaboration. A friend of mine who happens to have his PhD in fluid mechanics, in fact, work with Department of Petroleum Resources, and what his major primary work is to do what we call carry out the environmental impact analysis. So before anybody can open any filling station, there must be this test, environmental impact analysis. So somebody in the area of fluid mechanics can be a good, and you will be making your money there. So the person is a professor. Evaluation of total environmental impact of major development projects or industrial facilities. And a typical aspect addressed by modeling will be air, water, noise, traffic, thermal, ecological, and other issues. And then there will be what they call cost-benefit analysis of the alternatives. Then population dynamics. Population dynamics here can either be what we call the plant or animal. So ecological effects on plants and animal population of natural changes or perturbation by human action, e.g. overfishing, predator control, dams, and what have you. And somebody that is interested in carrying out the thing, what are the typical aspects that will be addressed? Will be retrospective or advanced evaluation of projects or government policies by model simulation. Environmental health impacts. Determining whether there is a connection between observed disease and some environmental cause or contributor. That will be the general overview, whoever that wants to carry out modeling on environmental health impacts. Now, what will be the typical aspect that is going to be addressed? Exposure modeling, statistical evaluation of suspected disease anomalies. The person has to take time. Let me just, by the time I do where I feel I want to, I will now take my time and then do further something there. Biodiversity is an issue. What will be the general overview, whoever that wants to work on that area? Preservation of diverse species and gene pools for reasons ranging from aesthetics to ecology to development of medicine and other products. Typical aspect addressed by modeling. Quantitative measurements of diversity and how it is affected by human actions or environmental changes. Wetlands. Wetlands are important for many reasons. That is, e.g., habitat, flood, erosion control, groundwater recharge, and what have you. Quantitative evaluation of value, either for advanced decision or setting charges for past damages. Desert growth. In many parts of the world, human overpopulation combined with poor conservation practices has led to growth of deserts in the areas of that were previously covered by vegetation. As somebody that wants to work, what will be the typical aspect to be addressed? Interactive effect of human activities and climatic episodes, viability of restoration programs, ionization radiation. Here, radiation, that is exposure from normal operation, nuclear power plants or accidents, disposal of radioactive waste. What will be the typical aspect area to be addressed? Environmental and health impacts of releases, probability of major accidents, suitability of waste disposal concepts, non-ionization radiation. Because I picked just about 25 areas that whoever that is interested can try to. Now, overview. Radiation from electromagnetic sources, such as power lines and electronic equipment. Typical aspect to be addressed by modeling. Estimation of population exposure at different levels. Statistical correlation with health data. Indoor air pollution. Indoor. And also, this is also another very area that, in fact, we are now in what they call the COVID-19. What are some of the indoor air pollution? Many substances in the indoor environment may be harmful. Radon gas, household material, etc. Movement of air pollutants through buildings' ventilation systems. Correlation of health impact to population exposure data. Noise pollution. An area of great importance of many projects is what they call in the airway. You keep on hearing people about everybody will just be this issue of using your own and what have you there. Airports, rest area, construction activities, windmills, industrial plants, you see what we call noise pollution. And there is an effect on human being. Anybody that wants to work on that area, what are the typical areas to be addressed? Advanced calculation of expected noise levels, evaluation of control strategies, so that somebody will not have what we call, will not have a air problem. Aesthetic degradation. Human aesthetic response to the environment recognized as a formal element of assessing environmental impact and degradation. Sometimes evaluated using quantitative ranking scheme to measure prevalence, preferences, and responses. Yes. Natural hazard, which is just something that just happened, that it's not a man-made thing. Natural environment occurrences can cause great environmental damage, like volcanoes, mudslides, forest fire, earthquake, floods. Example in Turkey, just some few weeks ago, we have this natural hazard thing that happened in Turkey. And also in California, about 2-3 weeks ago, there was this what we call the firestorm in California. Typically aspect addressed by modeling will be prediction, risk of damage to the engineering system, water supply, water, hazardous facility, cost effectiveness of investment to prevent or mitigate land subsidence. This is caused by underground mining, which if we look at in Zamfara right now, that is what is happening. Withdrawal of groundwater, underground dissolution of soluble rock formations, consolidation of sediments, and other factors. Zamfara State, Plateau, Nasarawa, they have this problem there. Prediction of such effects and evaluation of control measure. Rock mechanics modeling to change mining system. Saltwater incursion. Incursion of saltwater from the coastal area into a nearby aquifers due to overpumping. Whosoever that wants to carry out the modeling here will be interested in calculation of save yield by groundwater modeling. Now, let me now digress. We have some areas that in the next years to come, it will be difficult. There are some courses that if care is not taken, anybody that is reading such courses, if care is not taken, we just in the next 10 to 15 years. In fact, people will just say there is no point doing this type of thing because most of those things, event will have with the technology that we have now. And I want to just quickly see some of those things so that we need to be very, very careful. And that's why we keep on saying modeling is the main thing. Modeling will keep on to be very, very relevant. I remember about 4 years ago when we were asked to submit a research proposal. Some of my good friends from civil engineering and medicine, they submitted a fantastic things, but then they asked them at the third fund side there. They said, okay, yes, we've seen what you've done, but then are you not going to do what they call modeling of each of these things that you people have submitted? So what we're saying is there is hardly anything in science, technology, engineering that you will not have mathematics. And the basic mathematics you are going to have there will be the modeling issue. What are those hard to believe predictions that so many of us are saying that may soon be the reality of the whole world? Let us look at example. I'm quite sure most of us have received them in our WhatsApp. Auto repair shops will disappear. Where people will be telling me, I want to repair this. Why? 2, a petrol stroke diesel engine that has 20,000 individual parts will disappear. And what will replace it? An electrical motor that has just 20 instead of 20,000. Electric cars are sold with lifetime guarantees and only repaired by dealers. So it takes only 10 minutes to remove and replace an electric motor. So what we are saying is now, Those of us that have been using these our petrol or diesel engine cars, after some few years to come now, everything will be replaced with electric cars. 40 electric motors are not repaired in the dealership, but are sent to a regional repair shop that repairs them with robots. So instead of you calling any mechanic now, what we are now saying in some years to come now, in fact, it's just going to be a robot that will be doing the thing. Our electric motor that manufacture and that malfunction, that light just goes on, so you drive up to what looks like a car wash, your car is towed through while you have a cup of coffee, and out comes your car with a new electric motor. Petrol pumps will go away. Petrol pumps will go away. Street corners will have meters that dispense electricity. Companies will therefore install electrical recharging stations. In fact, they have already started in developed world. Smart major auto manufacturers have already designated money to start building new plants that only build electric cars now. Coal industry will go away. Gasoline, oil companies will go away. So what we are saying is drilling for oil will stop. So say bye-bye to OPEC. The Middle East will likely be in trouble, including Nigeria. So oil, we have to diversify. Homes will produce and store more electrical energy during the day, and then they will use and will sell it back to the grid. The grid stores it and dispenses it to industry that are high electricity user. Has anybody seen the Tesla roof? Which I'm quite sure by the time you go search, you'll see it again. A baby of today, we only see personal cars in museums. That is, the future is approaching faster than most of us can handle. In 1998, for example, Kodak had 170,000 employees. Kodak, a camera company, and sold 85% of all their photo papers worldwide within just a few years. Their business model disappeared and they went bankrupt. Who would have thought of that ever happening? But look at these days now, with the palm, just the Android phone, whatever you want, you can do. What happened to Kodak and Polaroid will happen in a lot of industries in the next 5 to 10 years. And most people don't see it coming. Those of us in modeling, this is the way we predict. Did you think in 1998 that 3 years later, you will never take pictures on film again? No. With today's smartphones, who even has a camera these days? With your smartphone, you do whatever you want to do. Yet, digital cameras were invented in the year 1975. So as with all exponential technologies, it was a disappointment for a time before it became way superior and became mainstream in only a few short years. It will now happen again, but much faster, with AI, artificial intelligence, health, autonomous and electric cars, education, 3D printing, agriculture, and jobs. I've been saying this to my students and to some of my colleagues, especially people in those days. You see everybody, science students, want to rush to do medicine. I've been telling people in the next 10 years to come, people will not be rushing medicine because people will want to embrace natural medicine, that is herbal medicine. 1. 2, most of the things that they do, say, there may not be need for you to do surgery that way. Now, forget the book, Future Software, Welcome to the 4th Industrial Revolution. Software has disrupted and will continue to disrupt most traditional industry in the next 5 to 10 years. Uber is just a software tool. They don't own any cars and are now the biggest taxi company in the whole world. Ask any taxi driver if they saw that one coming. So you don't even need to have a car. If I travel to Abuja to Lagos, all I need to do with my Uber thing, in fact, with some few minutes, they're already close to you. Then we have what we call Airbnb. Very good. I need to define this. The difference between this Airbnb and what we call bed and breakfast. I'm quite sure Professor Olaleru and so many other people that have traveled out are used to what we call bed and breakfast. Now, the difference between the two is this: in bed and breakfast, you will see that the owner or somebody that is employed to take care of you. But in this Airbnb, it's now the biggest hotel company in the world, although they don't own any single property. Ask Eaton's hotels if they saw that one coming. All you need to do, just from your bedroom here, you want to travel to Canada, you do your own key, then they will give you the instruction where the key is kept. You go there, a complete apartment. So the A there means A, B there means bed and breakfast. But then in most cases in Airbnb, you hardly see anybody there that will take care of you. It's you have the kitchen equipment, you have everything to yourself there. You can even go on holiday with your family. A complete apartment is reserved for you, and then you pay, you enter. Artificial intelligence. Computer become exponentially better in understanding the world. This year, a computer beats the best Go player in the world 10 years earlier than expected. In United States of America, young lawyers already don't get jobs. Why? Because of IBM's Watson, you can get a legal advice. So far, or right now, the basic stuff, within seconds, and with 90% accuracy, compared with 70% accuracy when done by humans. So if you study law, stop that immediately. Because the next future, I don't need to engage human being. All I need to do is just to get this software and then the same thing. So there will be 90% fewer lawyers in the future. What a thought. Watson already helps nurses diagnosing cancer. It is 4 times more accurate than using human nurses. So what are we saying here? Instead of you saying, okay, you want to use human being. Facebook now has a pattern recognition software that can recognize faces better than humans. In the year 2030, 10 years from now, computer will become more intelligent than humans. Autonomous cars. In year 2018, the first self-driving cars are already here. And in the next 2 years, the entire industry will start to be disrupted. You won't want to own a car anymore, as you will just call a car with your phone and it will show up at your location, drive you to your destination. You will not also need to park it. You only pay for the driving distance and then you productive while driving. The very young children of today will never get a driver's license anymore and will never own a car. That's a prediction. This will change our cities because we need 90 to 95 fewer cars. What are we saying here? Because of some of the things that I've said about some of this air pollution and what have you. So we can transform former parking spaces into green parks. About 1.2 million people die each year in car accidents worldwide, is reported, including distracted or drunk driving. We now have 1 accident in every 60,000 miles. With autonomous driving, that will drop to 1 accident in 6 million miles, and that will save 1 million lives plus worldwide each year. Most traditional car companies will doubtless become bankrupt. Why? They will try the evolutionary approach and just build a better car. While tech companies, Tesla, Apple, Google, will do the revolutionary approach and build a computer on wheels. Look at what Volvo is doing right now. No more internal combustion engines, in their vehicles, starting from last year. Using all electric or hybrid only, with the intent of phasing out hybrid models. Many engineers from Volkswagen and Audi are completely terrified of Tesla, and they should be. Look at all the companies offering all electric vehicles. That was unheard for some few years ago. Insurance company, we have massive trouble because without accidents, the cost will become cheaper. Their car insurance business model will disappear. Real estate will change. What am I saying here? If you can walk while you commute, people will abandon their towers to move far away to more beautiful, affordable neighborhoods. And electric cars will become mainstream about the year 2030. Cities will be less noisy because all new cars will run on electricity. And cities will have much cleaner air as well. Electricity will become incredibly cheap and clean. This is point 35. Let me diversify here. We renewable energies from the solar and the wind electricity. Federal government established 2 nuclear centers, one in Obafemi Awolowo, one in ABU. They established 2 solar and renewable centers, one in Usman Danfodio and one in UNN Usuka. So, solar production has been on an exponential curve for 30 years. But you can now see the impact as it is just getting wrapped up. What are we saying here? Most people have now said, in fact, it is initial cost of setting up the solar. Because if you look at each cost of solar panel, if you are looking at maybe say something like 250 watts for 40,000, 300 watts for 50,000, 500 watts now for 110,000. And you may need about 10, it depends on what and what you want to use the 10 for. At long run, you are going to save costs of powering your generator. NEPA here, or what they call power holding, electricity is not stable. But right now I'm on my generator. Yes, I equally have the solar panel there, but most of my batteries, the 4 batteries I'm using, they can't last long. So, and I don't want to gamble. So I need to replace them. So fossil energy companies are desperately trying to limit access to the grid to prevent competition from home solar installation. But that simply cannot continue. Technology will take care of that strategy, whether we like it or not. On Earth, there is what we call Tricoder X. Tricoder X prize will be announced this year. There are companies already. There are companies who will build a medical device called Tricoder from Star Trek that works with your phone, which takes your retina scan, your blood sample, and your breath into it. It then analyzes 54 biomarkers that will identify nearly any disease. There are dozens of phone apples out there right now for health purposes. So of what use will it be for me to go to my school university clinic when I know that most of these things I can use my Android phone and get whether I have the BP, whether I have what they call the glucose, whether I have this health problem and what have you. So we should all welcome to tomorrow, and it actually arrived a few years from now. So let us all wake up to 21st century challenges, and let us all prepare for the future right now. So I will pause here to take some questions so that I can be able to answer. Thank you very much.
Thank you very much, Professor.
You're welcome.
We appreciate your lecture.
Thank you very much.
And I know you have opened the eyes of many of us to research areas that they can concentrate on.
Oh, yes.
If you don't have PhD, well, you don't have problem with research areas anymore. Even if you have PhD, you need to write more papers.
Oh, yes.
And impact more in the lives of people through your research. So thank you very, very much.
You are welcome, sir.
We welcome questions. I think, I guess everybody is on mute. Okay, you can read. The host will unmute you. On the other, yes. just raise up your hand. The host will unmute you. On the other hand, you can also send your question to the chat box so that can be given to them. So send your question or raise up your hand, and then the host will unmute you. Yeah. Can you unmute Tumbi for us? He's raising up his hand. Host, can you unmute Tumbi for us?
He can unmute himself.
Okay, Dr. yourself. Dr. Fatumbi, unmute yourself and ask your question.
Hello.
Yeah, you can ask the question.
Okay, thank you, Prof, for this wonderful presentation, sir. My question is on environmental impact analysis that Prof
Oh,
mentioned.
yes.
That somebody who work on study fluid metrics can also focus on that. I just need more
Yes.
explanation, sir. And how can somebody in fluid metrics, for example, myself, I'm interested in that area that you mentioned, environmental impact analysis. So that's exactly what I want you to shed more light on that area, sir. Thank you, sir.
Okay. Environmental impact assessment. Suitability of the place. Like I told you before, anybody can be given a license to operate what they call petrol or fuel station. Somebody in this area must first of all go for what they call environmental impact assessment. What are those things? Check the land, suitability. If the person is able to now bring in the liquid, you understand now?
Yes, sir.
What are the depthness, you understand now? You look at how deep and what have you. And what are those things that will make the person not to run a business at loss? Are you with me?
Yes, sir.
Then the environmental pollution also will be taken into consideration. How close is it to people residential building? Because by law, in fact, it's forbidden. But I've seen so many family houses, people because of poverty, they just dispose the family houses because anybody that just want to build can say, okay, please, I don't mind to give you 20 million, 50 million. But at long run, a good person that is working on environmental impact assessment will say no to that under the Department of Petroleum Resources. But then if you want to, you can just contact me if you look at my slides to know
Okay.
more. Because
Okay.
I've been saying so that those of us, let me just give you this too. And I'm quite sure Professor Laleru and the moderators will allow me to highlight some things. I'm happy in Unilag there, you have people in fluid mechanics. Especially I'm aware of Dr. Abiala is in fluid stroke solid mechanics. But you see, I've been laying emphasis here in Ilorin when I came back that any course don't just be good in only the theoretical aspect. Try to understand the physical interpretation. Are you with me?
Yes, sir.
Hello, one should be able to understand the physical interpretation. Just like I said 2 days ago, if you have this continuity equation, you have the energy, you have the momentum, and you have the species or the concentration. These are the things that we play with, isn't it? In fluid mechanics.
Yes, sir.
Very good. Now you put your assumptions, but to a good person, I remember I went to one seminar and the question I asked was that, okay, the person, a PhD in fluid mechanics, show me where you derive your velocity from. You understand now? When you talk about velocity profile, temperature, so anybody that is in fluid mechanics should be able to know when you say momentum is mass times what? Velocity. Are you with me?
Yes.
Let people understand the very. Okay. Then if you talk about heat is in form of what? Temperature.
Yeah,
then your temperature profile, you show people is gotten from this equation. Then you now come to a layman terminology, explain so that people will see the beauty of what we do, not this issue of long equation. I'm quite sure Professor Olaleru will not be interested in all this our long equation. We want you to say, okay, tell me the interpretation. Because this is mathematics that we are just dealing with. Differential equation, partial differential equation. From partial differential equation, collapse to ODE. From the ODE, you now talk about numerical solution.
Yes.
But then we should be able to explain each of our equation so that even somebody that is from economics, we see the beauty. The same thing in solid mechanics, which we call the vibration. I'm happy you have a Dr. We call him Abiala. He's also a lecturer in Unilab there.
Yes, sir.
Beam, plate, and shell. These are the three things I will play about. Beam, plate, and shell under the vibration. Okay? Now, if you are telling me that, okay, what is going to happen to this? I want to look at the natural frequency. I want to look at this one. You let people understand the beauty. Not only the mathematical equation. Until we get to that. And anybody also doing numerical, I've been telling people, you won't just do numerical and say, the Okoya own tallies with Okonoga and Taiwo tallies. No! Numerical analysis has passed that. You should be able to show people. I remember I was in Texas A&M University in US, and there was this numerical analyst chap. He got $1 million contract from oil company in Saudi Arabia. A numerical analyst. And what was he looking at? You can see it here now. He's looking at the fluid. You understand now? But in Nigeria, like some of our people, they will tell you, sorry, our own is just to tell you we have this formula. So it's left for you to go and find the application. No! Please, that era has gone. We lecturers should be able to show mentor very well. Because that is what is killing the real academics now. By the time you travel out of Nigeria now, and then people, you'll see somebody in algebra. Ask Professor Laleru, even in Cameroon, there in Ghana. You see people in algebra and they're telling you the application. You see people in functional giving you the application of functional analysis. You see people in complex giving you the application. But here in Nigeria, somebody will just tell me, no, it is not our own. Another set of people will now use that one and no! So please take my number in the slide that I've passed around. You see my email for further explanation and for some of the textbooks that I may equally recommend for you. Then I will link you up with that person. His name is Professor Ismail Akpa. He's a professor of fluid mechanics in Usmana Fudio.
Thank you very much, sir. Thank you, sir.
Hello, thank you, Professor Ibrahim. If you look at the chat box, you will see some other questions.
Sir?
If you look at the chat box, there are some other questions there.
Okay, let me see. Sorry.
Dr. Lalo, what is it?
Thanks. That's what I want to quickly check now. So that I can quickly just add them. The chat.
Okay,
Start
explain
box.
the
I'm coming. I want to write. Start box.
answering them so
I
that
want
they.
to write. I'm coming.
Oh, sorry, you can't see them,
Yes.
Abi. I can
No,
ask.
I've
Can
seen
I
it.
read
I've
it?
seen it.
Okay, okay, okay,
Don't worry. Don't worry. I've seen it. Please, Prof.
okay.
I have my PhD in mathematics, but not in modeling. But not in modeling. The question is, if I want to go into modeling, is it going to be okay and easy? And if I have to go into modeling, how do I go about it? Thank you. To answer you, I don't know whether, okay, you say you already have your PhD. Dr. Elijah. Yes, you're always welcome. You see, if you ask my good friend there and my brother, Professor Olaleru, it's only here in Nigeria we are yet to start what they call postdoctoral. But outside the country, and I'm happy. Look at Professor Trump, 2 PhD, one in physics, one in mathematics. You see? So there is nothing that stops you from not getting. You are always welcome. But then we have to recommend some textbooks for you. And I need to equally know your background, your PhD background, because it's very, very important. Because if not, here in Nigeria that we don't have a, excuse me, you know, we don't have a postdoc here. So, and it may take you some few months or some few years. It depends on your background. Then I have another person, I don't know whether the person is also a PhD holder, from Ufoma. Thank you, sir, for the exposition.
Sorry,
Sir.
Professor Ibrahim.
Yes, sir.
Professor Ibrahim.
Yes, sir.
Mathematics concepts that you need to know if you want to work in modeling.
Sir?
I think it's
You say
good
what?
you tell him the mathematics concepts you need to know if you want to work in modeling.
Okay, very good. Now, first of all, like I said earlier, let me repeat myself again. You still need to dust. If you are in Lagos, I'm quite sure Professor Laleru is there for you for functional analysis and possibly complex, because you still need to, and topology. Because we are what we call homotopic analysis method. The textbook I have it there. It's still going to be part of the textbook I'm going to recommend for people. So you need to be good in algebra, functional analysis, complex, topology, what we call a mathematical method. That is ODE, PDE, numerical analysis, and optimization. So if you have this, then it will not be difficult for me or any other modeler to be able to take you. But you must be sound in algebra, functional analysis, complex analysis, topology, numerical analysis, optimization. Because you see, I use what they call optimal control here. And that's my trademark. Most of my students, in fact, most of the external examiners, once they come and they say, oh, you must have passed through MO, because that's my trademark. That's the way I supervise my students. So I go from numerical to optimization and even to cost benefit analysis, which we call health economics. So you must be good. Then I can add some textbooks for you. And then by the time you read it, if you don't understand, it's in Lagos, very private by me. I can direct you to Dr. Ayuade. In fact, I must be grateful to Professor Olaleru. Singularly, it was a result of our meeting in Abuja, and he said, Emu, I would like you to give us one of your PhD students. Unfortunately, Ayuade has completed his PhD as far back as I think almost this should be the 3rd year. And that was how Ayuade was taken. So if you want to know about modeling, Dr. Ayuade is there for you. So I don't know whether you are satisfied with that. So there is this lady that talked about will the increase in importance of American modeling to increase in importance of pure mathematician? Yes, there is no way, you see, you can't have what we call apply. It's only here there you say pure, I mean apply. Every one of us must, you must pass through algebra. When you talk about characteristics equation, is it not part of the thing that is there in both linear algebra and what have you? You have to know all those things. That's why I keep on saying, you must know. You do your algebra, you do your functional analysis, complex analysis, because under this optimal control thing, we talk about concavity and convexity. So you must do, and numerical, most real life situation cannot be solved analytically. You have to resort to what we call numerical methods. So most of my students, I expose them to the following area: variational iterative method, DTM, alternative direction method, ADM, parameter expansion method, arm method, homotopy perturbation method, and what have you. So this is the way we do. So, and there is a question from, I don't know if Prof can recommend some literatures for beginner in this great area of modeling. Don't worry, I'm going to send this last part of my lecture together with some recommended textbooks. So if you want to know more about anything, just always feel free, see Professor Laleru, because it's my link. So I don't want to bypass him. Anything I want to share, I want to share.
Any other question, please be free to ask. If you have any other question, either you raise up your hand, you will be unmuted and ask, or you send it through the chat box. So can I assume that all questions? Okay, Oluwa Femi Bada, you can unmute yourself and ask your question. Yes, ask your question.
Thank you, Prof, for the wonderful lecture, sir. Sir, I want to ask for, like, I've been having issue anytime I'm working on my having issue every time I'm working on how to plot the graph of a backward bifurcation graph. So I don't know if, Prof, sir, if you can help me out on that, sir. Hello?
Professor Ibrahim, you are free to answer. Professor Ibrahim.
Hello?
You are free to answer. Have you asked the question?
Yes, I'm asking him, is he based in Lagos or Ibadan?
No, I'm presently in Ondo State.
Okay. If you are in Ondo State, I may give you a number of one of my students also there.
All right, sir.
And I'm quite sure also Ondo is not far from Ibadan.
Yes, sir.
So I'm quite sure you'll see my number there, or I can just read out my number: 070
Yes.
3294. Another backup number in case if you try there is no network. 080
Yes, sir.
53 0805363 3541.
All right, sir.
Okay. Are you doing your master's or PhD? Or it's just a test, a paper?
So I'm thinking of continuing with PhD when when I am fit enough to
Huh?
do that, sir.
You say what?
I said, I've rounded up my master program
Okay, from where?
from University of Benin.
Oh, Benin. Okay. Who supervised you there?
Uh, Professor Robert, Professor Dan.
Dan. Okay,
Professor,
okay, okay, okay. Okay, okay, okay. No problem. So you have my two numbers. In case if
yes, sir.
you try my MTN and it's not going, try my Glow. Because I'm based here in Ilorin for the time being. So there is no way you will not get me. But I have 4 different lines. I have Airtel, I have Chisalat, and what have you. But these 2 different handsets. So feel free so that I can just direct you in case if you're unable to meet me, I can just direct you to somebody that is very close to you and you won't spend much. You understand? Thank you.
Yes, sir. Thank you very much, sir.
Yes. More questions?
Any other question? For your information, if you look at the chat box, you will see pressure there. So you can copy them. So any question again? Just raise up your hand or you
Because
type.
I want it to be very, very lively. You understand? That's why I'm avoiding all these our dy, dx, SR is equal to this and what have you. So let us make the thing lively and some area for further research or even for paper publication. Because I will definitely crack some jokes and ask us some things so that it will open our eyes to what we call the way we model. Yes.
Please, Suleiman, I think Dr. Suleiman also. By now, you should learn how to rename. Suleiman, you should learn how to rename. Just go to participants. Under participants, you will see your techno. Then click it. When you click it, it will bring out different options. Click rename and then put your name there. Normally, we shouldn't have allowed you to, we shouldn't have admitted you with without your name. The person using Techno Spark, that's Suleiman. Can you unmute, Suleiman? Can you unmute? Suleiman, can you unmute yourself? The person using Techno Spark, if you are hearing me. Techno Spark, can you unmute? At least by now we should know how to use this Zoom better after passing through this lecture. Suleiman? Okay, I'm not sure whether he's hearing me at all. So, any other question before we call it a day? I want to appreciate every one of us for being here. Tomorrow will be a special day. We are learning about LaTeX. And I've made it open for everybody, even those who don't have money to register. They are LaTeX class. I've sent the code to our Telegram. So you should just download the software. It's already in the platform. And then tomorrow morning by 9, use the code that is there. Tell others who could not register because of money or one thing or the other. We don't have any choice as mathematicians than to learn LaTeX. For example, our journal, we don't take any other journal, any other article except the one that is written with LaTeX. So, and that's the international, the global norm. So tell others and let them join us. Then on Saturday, we finish up with our workshop lectures. Let's make the best use of this so that we'll be able to be empowered for better productivity in our research areas. Then coming Wednesday, we are going to do presentation of papers. If you are presenting paper, please send your PowerPoint now for us. If you don't send your PowerPoint, we assume that you are not ready to present the paper. And by implication, we will not give you certificate of presentation. We will only give you certificate of attendance. So it's better you just send the PowerPoint to that's jamsat@unilad.edu.ng. So thank you very much. Have a good. Thank you.
Good afternoon, Prof.
Yeah, good afternoon.
Yes, sir.
I can hear you. Eh?
Yes, sir. I was actually trying to call the attention of Professor Olaleru, sir.
Okay, you can
Oh,
speak
okay,
on.
sorry.
Yes, sir. My name is Babatunde Omoju from Maritime Academy of Nigeria.
Okay.
Yes, sir. I just with regards to the presentation of paper, I've been able to send. Yes, I've been able to send my slide, with my co-presenter. I think yesterday, but I just wanted to be sure that it was received. Maybe a form of acknowledgement.
We want to send it to the right email. It will have been received. That's jam@unilad.edu.ng.
I did that, sir.
Definitely, they will have received it.
Thank you,
Please,
sir.
if you are not presenting papers, still join the conference that is coming up, because when people have more ideas of research areas and how people go about their research, in your knowledge. So it's not only for those who have papers. So thank you very much.
So people are still allowed, yeah, they are free to, so that we do what they call discussion for the next 20, 25 minutes. If you have anything you want me to shed more light, please feel free. I always try to do what they call time management. And if you don't have, maybe I will now share some of these things with you. Because you see, those people in fluid mechanics, those of us in fluid mechanics, should also try to get some latest journal on what they call climatic modeling. Because you see, fluid is so vast that it's not an area that just limit to only the water flow and the air. Hello? I'm quite sure we still have some participants. Hello?
Hello, sir.
Yes, we still have.
Hello?
Yes, we still have.
Oh, very good. So what I'm trying to say
We are listening to you.
is this. We have so many areas under what we call climatic modeling. Climate. So, you see, weather prediction, what they do in NIMET, Nigeria Meteorological something agency in Abuja there, is nothing but what they call climatic modeling. And part of it is also what we call an aspect, subset of climatic modeling is what we call the space dynamics. What do they do in space dynamics? We have three things that we watch. The three moving body: moon, sun, and star. MSS. Moon, sun, and star. So somebody in space dynamics can work in physics department and can equally work in engineering department. What are those tools that we use? General and dynamical system. That's all. So you relate the movement of these three bodies: moon, sun, and star. So it's a pity that most of us, people will just limit their area of focus to their area of supervisor. Once you bag your PhD, that is even the beginning. You will now start thorough research, the area you want people to reckon to know you. So you will not just stop. If you are in magneto hydrodynamics, that is not just all. You keep on researching. Look at Professor Christopher Tron. From mathematics to physics to software. Is it not funny? Look at it, from mathematics to physics to software. So it can fit into all these three areas. If you talk about Python now, in fact, before you know it, Professor Tron is #1, as far as I'm concerned. For us here in Nigeria, he will do it and you will think it's even a professor of computer. So that is development, and that is what Professor Laleru is saying. Knowledge, don't say now I'm not a PhD holder and I feel this is just what. No, don't narrow yourself down. And I'm happy there was just a lecturer from Federal University of Petroleum, Efirum. Is he still there? Or he has left? You see, there they work. Anybody that is a mass department should be able to provide solution to oil bunkering. Oil bunkering that is also known also over there. So you won't say I'm in fluid mechanics, but I don't know anything about petroleum. If you are in Department of Mathematics there. Because is petrol not part of fluid? It's part. And for you to be relevant, especially to all these oil companies, then you have to know some of these bit of some modeling. So that you won't just limit yourself. Most of the thing they're doing in Shell is computational fluid dynamics, geophysical flow. That's what they do. Geophysical flow. So please, I'm urging of you, the young shall grow, and you are growing. And it's our prayer. Please, should be the beginning. Try, even if a senior lecturer. If you have a specific area that you want to pick the interest on, get some of those textbooks first. Read. Get some experts that will now be able to see you through. And that's the way we get knowledge. But for somebody to say, no, I'm a professor of this in America, and people now said, okay, sorry, I'm from chemical engineering. Please, can you now tell me which of the methods will be better? And you said, no, my own type of numerical is that I know linear multi-step method only. No! So they approach you, you now said you only know conjugate gradient method in optimization. They now say that you should be able to talk about industrial optimization now. So please, I'm appealing to those of us that are lecturers. Anything we are teaching, let us try to get a practical or physical understanding of the equation. That is the only way. Because mathematics, most people are running away from it. I discovered that if not for the topic big data, if you look at how many people attended the Trump thing because of that big data thing, and that of that woman again, Dr. Bombo, because she's able to relay computer thing. But once you introduce mathematics, people will start running away one after the other. Because people don't want to hear. If not the physical interpretation, people want to run away. But even medical doctors are now interested in even in this our health modeling thing. Because their own is that they know malaria. Yes, it exists. But then, what is the modeling behind it? What is this reproductive number thing? The same thing with this COVID thing now. Go to some universities in America now, in fact, they've pumped several millions of dollars to modeling of COVID-19. So please